what features or maybe characteristic has allowed there to be a need for an expert system. So there are a lot of characteristics or features, but I'm only going to be kind of giving a brief overview on 6 features. So no memory limitations. It's pretty clear, but expert system can store as much data as needed, and they can memorize it during applications. Unlike humans, we're not able to memorize as much as we want. We do not have the capability to memorize everything. High efficiency. For there to be high efficiency with expert system, the knowledge base needs to be kept up to date with the correct information. Expertise in a domain. Because in expert system, the knowledge or the skills, the experiences, abilities of a lot of different human experts are incorporated in one knowledge base. It makes it easy to produce an efficient output by combining all of the facts, all of the knowledge. Not affected by human emotions. As it is not a human, it's not clouded by emotions in its judgment. High security, they provide high security, they check and consider all the facts. So what are the capabilities of expert system? What actions or tasks are they capable of doing? So they can advise, diagnosis, as I've already said, health diagnosis, they're used in medical diagnosis. They can provide assistance in human decision making. They can provide instructions and demonstrations. And they can also provide suggestions for alternative solutions to a problem. Components of an expert system. Well, what are the components that make up expert system? So it basically has 5 components, 4 if you don't count a user interface. They are knowledge base, inference engine, knowledge acquisition system, and lastly, explanatory mechanism. I'm just going to slightly give a brief overview on all 4 components. User interface, I don't think I'll really have to talk about. So knowledge base contains knowledge in a specific domain. So each expert system is focused on only one domain. So the knowledge base is a type of storage which contains knowledge which is gathered from various domain experts. And the knowledge base not only contains facts, but it also contains rules for solving problems and forming procedures relevant to the domain. And there are 2 types of knowledge. You have factual knowledge, which is based on facts, and you have heuristic knowledge, which is based on practice. It allows you the ability to guess from the countless evaluations, your experiences. And inference engine. So inference engine is kind of like the brain or the heart of the expert system. And its basic function is to obtain relevant data from the knowledge base, interpret the knowledge or the data, and then find a solution to the user's problems. And they're also capable of explaining and debugging. There are 2 types of inference engine, deterministic inference engine and probabilistic inference engine. With a deterministic inference engine, it is made up of Boolean or classical logic. So 0, 1, yes, no, basically 2. And so the conclusions, whatever the conclusion is reached at the end by the inference engine, they're assumed to be correct because it is founded on facts, it is founded on regulations. And probabilistic inference engine is pretty clear by the name itself. It is based on probability. So the conclusion contains uncertainty. And it uses the following strategies to recommend solutions. So it's backward chaining and forward chaining. However, fuzzy logic is also associated with inference engine. Fuzzy logic is basically the approach to computing. So there's various degrees of truth rather than just true or false. There are how we say there's no black and white, there's shades of gray in between. It's similar to that. Backward chaining is a method of reasoning where you start with a conclusion and you work backward to come up with the facts, right? So expert system would employ a backward chaining if it wants to answer the question, why did this happen? right? So it attempts to identify the conditions that could have occurred in the past to trigger the final result based on what has already occurred. It is used to determine the cause or reason for an event. In forward chaining, expert system asks the question, what could happen next, right? So here we're trying to come up with a conclusion. We have this fact, and then we try to decide what could happen next from here. And in this, it considers all the facts, all the rules, and then it follows a chain of conditions and derivation. And after sorting them, it reaches a conclusion about the best solution. So forward chaining is used when you want to reach a conclusion, you want to reach a result or effect. An example would be if you're trying to predict how the stock market will react to changes in interest rates, for example. Knowledge acquisition system, this is pretty clear. Also is a component which allows the expert system to acquire more data from various sources and then store it in the knowledge base. Explanation module, so once it gives the conclusion, it helps to explain the conclusion to the user. This is a brief figure or a simple figure of an expert system. There are various figures online. This is the one that I chose to put. And what is happening here in this diagram is that the expert system or the non-expert user is interacting with the expert system through a user interface. And this interface accepts queries, which is in a readable format. And then the query is passed into the inference engine. And then this inference engine applies inference rules to the knowledge base to derive a conclusion in terms of forward chaining, and to deduce new information in terms of backward chaining. And the knowledge base, as I've already said, the knowledge that goes there is provided from experts, human experts. So who are the participants in the development of an expert system? So basically, I would say there are three people or groups, I could say. So the human expert, right, which is very critical to the success of an expert system because they are the ones who provide a specialized knowledge in a particular domain. And then you have knowledge engineer, which translates this human expertise. So the knowledge or this knowledge from the humans, it is translated into a system, a knowledge-based system, which can replicate or not replicate, but come up with the same answer or come up with the same conclusion that a human expert would, right? So in addition to the knowledge itself, it needs to decide the rules of how to apply it in different circumstances. And end users are basically non-experts who would query the expert system to answer their questions or queries. Advantages. What are the advantages of an expert system? Okay, so there are multiple advantages. I also have only chosen 6 here. Availability, meaning that they can be easily available due to mass production of software. Less production cost. They're pretty reasonable and affordable. Speed, they obviously offer great speed and reduce the amount of work. Less error rate, low risk. Meaning they're capable of working in environments that are dangerous to humans, hazardous environments where environment, steady response, they're not troubled by fatigue or tension or any of that sort. Limitations or disadvantages, right? So no technology or there's nothing available in the market which is completely perfect in terms of providing simple as well as comprehensive solutions. Large systems are expensive but they also require a substantial amount of development time as well as resources, right? And expert system has the following limitations. It requires constant manual updates. It cannot learn by itself. The knowledge base needs to be constantly updated. Development and maintenance cost is very high. It is why its expert system is also not quite used because of the cost itself. Difficult knowledge acquisition. It only adheres to specific domains. Yeah, so uh, applications. So it can be used in medical domain diagnosis system to deduce the cause of disease from data. Commerce in commerce, yeah, detection of possible fraud, suspicious transactions, maybe regarding stock market, airlines scheduling, cargo scheduling, monitoring systems. It can compare data continuously with observed systems. Knowledge domain, finding faults in vehicles or computers. Yeah, but however, I don't think expert system can ever replace a human expert, because whenever we come up with decisions or we think, our thoughts are never linear. They're very non-linear thought process. We do not make decisions in a linear manner. So the knowledge engineers will never be able to replicate our thought process, because we make decisions based on intuition, our gut instincts, our previous experiences, and we learn from the mistakes we've made in the past. However, they can come up with the same results without following the same line of thought. That is all for today. Thank you very much.